logic functions. The first logic function is the AND function, and with the AND function we're taking our inputs and we are placing them in series with each other, and as a result, if we're looking at A and B as my inputs and Q as my output, then we see that if A and B are both open, the output is off. If I close A or B, then the other one will still keep the output off, but the moment I close both of them, I've got a clear connection and the output will turn on. To represent this in a functional block diagram, we use the AND symbol. A and B gets ANDed, and that gives me my output. The American symbol looks like that, and representing it in Boolean, we can see that Q is dependent as the product of A and B. If they both 1, then the output will be 1. The moment I've got a 0 on the input, the output automatically turns to 0. The next function is the OR function. Ladder diagram, A, B are connected in parallel with each other, and we've got Q on the output, and we can see that if A and B are the inputs and Q is the output, if both A and B are open, then the output will be off. If I close B, then I've got a connection to Q, which will turn it on. If I close A, I've got a connection to Q, which will turn it on. And if I close both of them, then both of them will connect and to Q will turn on. To represent this in expression, we say A plus B. Symbol A and B greater or equal to 1 to give me Q. Now if we compare these two, we see that if the sum of A and B is greater or equal to 1, then the output will turn on. 0 plus 1 is 1, 1 plus 1 is 2, which is greater or equal to 1, which means it turns on. The American symbol gives us the same function. Now the NOT function, or the invert function, we're taking our input, say A, and we're connecting it to Q, but instead of taking the input like that, we use that symbol. Now what that basically does is it tells the PLC that if A is a 1, it must read it as a 0, and if A is a 0, it must read it as a 1. So comparing A and Q, if A is 0, Q is going to be on, and if A is on, then Q is going to be off. The symbols are clearly distinguished by the bubble function, or the inverse circle on the output, to represent that the value gets inverted. The American symbol, same with the bubble function or the invert function, which will give us the invert of the logic gate. Now we can combine the NOT with the AND and the OR, and that will give us the following. If I look at A and B in series, and I do that to Q, then A and B, 0, 1, 1, 0, 1, 1. As they are in series, they will A and B, which will give us 0, 0, 0, 1 over there. But because I have knotted the output, Q1 will be a 0 turns to a 1, and a 1 turns to a 0, which means that the output will be off whenever all the inputs are on. We can take this a step further and do the OR. Okay, this is the NAND function, A and B, Q2 knotted, because they are in parallel, A and B, because they are in parallel, A and B are ORed, so we're saying A plus B, so there's 0, 1, 1, greater or equal is 1, and as a result Q2 will be 1, 0, 0, 0. That's A plus B over there. Okay, so now looking at these, this will be the NOR function. When I take the NAND, it is a combination of the NOT and the AND function, so we will represent it as A and B, which gets knotted to give me Q1. The American symbol for the NAND is the same as the normal AND symbol, except with the bubble function. When it comes to the NOR, we're saying A, B goes into my OR, and the output gets knotted to give me Q, and the symbol same as the OR, except for the inverse. Here I've got the American symbols, there I've got the IEC symbols.